If you're building a RAG system, you know the quality of your answers is only as good as the data you feed it. But here's the real question. How do you get that data into the system correctly in the first place? Well, today, we're zeroing in on the most critical piece of the puzzle, the foundation. And it all begins with document loaders.
You've probably heard this a million times in engineering, and for AI, it's the absolute truth. Garbage in, garbage out. If the info you're feeding your system is messy, incomplete, or just plain wrong, there's no way you're going to get smart, accurate answers back. This isn't just a catchy phrase, it is, without a doubt, the single most important concept for RAG data ingestion.
And the impact? It's not small. Not by a long shot. Just look at this. The difference between a clean, well-structured loading process and a sloppy one can mean a system that's 90% accurate versus one that's barely hitting 60%. That is a huge gap. It's the difference between a tool people actually trust and use and one they just give up on. The stakes are incredibly high from the very first step.
So here's the game plan for this explainer. We'll kick things off by really defining what garbage even looks like. Then we'll dive into the biggest headache for everyone, PDFs. After that, we'll cover other common stuff like web pages, Word docs, and code. I'll introduce you to a really powerful pattern called the universal loader, and then we'll wrap up with the essential finishing touches that take good data and make it truly great. All right, let's jump in. Section 1. Garbage in, garbage out. We're going to get super specific about what can go wrong and why this first step is so crucial. This is really where quality is either locked in or lost for good.
So what does poor extraction actually mean in practice? Well, it means your system might just completely miss critical paragraphs. It can mean your text turns into a garbled mess of characters thanks to encoding errors. It means that all that vital structure like tables and headings that give everything context is just gone. And often, it means all the super valuable metadata, like who wrote the document and when, is simply thrown away. Each one of these errors literally poisons the well for your RAG system.
Okay, moving right along to our second section, let's talk about the PDF puzzle. If you've ever tried to build an AI system, you know this is a massive headache. PDFs are absolutely everywhere, but let's be real, they were never designed for easy data extraction.
And this is what's so interesting. This is why PDFs are so tough. At their core, they're about presentation, how things look, not about the data itself. Some of them are just images of text, which means you need something called optical character recognition, or OCR. They can have these insanely complex tables and multiple columns that are a total nightmare to parse. Plus, you have to filter out all that noise like headers, footers, and page numbers.
So where do you even start? Well, for the super simple text-only documents, a tool like PyPDF2 is a decent first step. It's easy to use, but it pretty much falls apart the second it sees a table or a complex layout. A step up from that is PDF Plumber. It's way better at spotting and pulling out tables, but the trade-off is that it can be slower and it still gets tripped up by the really complicated stuff.
Now, when you're ready to get serious and build a real production-grade system, you need the heavy hitters. Unstructured.io is fantastic for those complex documents. It really excels at understanding layouts and even has OCR support built right in. The catch? It can be a bit slower. On the other end of the spectrum, you have PyMuPDF, which you might also see called FITS. It is incredibly fast, which makes it perfect for when speed is everything, but you might lose a little bit of that fine-grained table structure detail.
And what about those scanned documents we were talking about? That's where OCR becomes your best friend. The go-to open-source option is Tesseract. It's free, and honestly, the quality is surprisingly good. But if you need the absolute best performance, especially for tricky tables and forms, the cloud services from AWS, Google, and Azure are just in a different league. You get what you pay for, and the quality is definitely superior.
Okay, so we've laid our PDF foundation. Now, for Section 3, let's start framing the walls by looking at other common data sources, web pages, Microsoft Word documents, and even source code. Believe me, each one has its own unique quirks.
When you're pulling content from the web, you've basically got three main strategies. Beautiful Soup gives you complete manual control, which is awesome for static pages where you need to write some custom logic. If you just want the main article content and none of the junk, Trafalatora is amazing. It automatically strips out all the boilerplate like ads and navigation menus. And for all those modern dynamic websites that run on JavaScript, you're going to need a tool like Playwright or Selenium to actually render the page first before you can grab the content. Loading Word documents is, thankfully, a little more straightforward. The standard library, Python Docs, does a really great job for most files, keeping your paragraphs and basic tables intact. But just like with PDFs, if you find yourself dealing with super complex enterprise documents that are full of crazy tables and embedded objects, a more comprehensive tool like Unstructured.io is going to give you a much cleaner result.
And what about source code? I mean, sure, you could just read it in as plain text. It's fast, it's easy, but you lose all the logical structure. A much more powerful syntax-aware way to do it is to use a parser like TreeSitter. It actually understands the code's structure, so it can preserve the boundaries of things like functions and classes. That provides crucial context for any code-related questions.
This all brings us to a really powerful idea in Section 4, the universal loader. I mean, after seeing all these different tools for all these different file types, you might be wondering, isn't there a simpler way to handle all this madness?
And that's the million-dollar question, right? As your project gets bigger, you're definitely going to have to handle PDFs, Word docs, web pages, you name it. Do you really want to be writing and maintaining totally separate loading logic for every single one? Probably not.
The answer is a design pattern called the universal loader. Now, this isn't a single tool, but it's more of an architectural approach. The idea is you have one single unified interface that can intelligently handle any document you throw at it. It's a game-changing strategic choice for any serious project dealing with multiple file formats.
And this slide right here perfectly illustrates the power of that pattern. A library like Unstructured.io basically implements this whole idea for you. With just one consistent API, it can automatically figure out and parse dozens of formats. We're talking everything from Office docs and PDFs to emails and even images, using its built-in OCR. This just dramatically simplifies your entire ingestion pipeline.
Okay, great, we've loaded our data. But hey, we're not done yet. In our final section, we're going to add the essential finishing touches. This is that professional polish that really separates a quick prototype from a truly production-ready system.
So here's a crucial point. The text content is only half the story. You absolutely have to extract the metadata. Knowing the source file name, the page number, or the section heading provides priceless context that your RAG system can use to give you better and, more importantly, attributable answers.
So once you have the text and the metadata, it's cleanup time. And this is basically a non-negotiable checklist. You've got to normalize white space, get rid of those pesky headers and footers, handle different Unicode characters to avoid errors, and even fix common little mistakes made by OCR systems. This is all to make sure the final text is absolutely pristine. And what happens when you have thousands or even millions of documents? Well, you have to start thinking about performance. Two key techniques here are parallel loading, which just means you process a bunch of files at once, and caching. Caching is genius. You save the processed result of a file, and if that file hasn't changed, you never have to waste time processing it all over again.
So let's bring it all home. From picking the perfect parser for a complex PDF, to cleaning up white space, to caching the results, every single one of these steps matters. The ultimate quality and reliability of your RAG system is a direct, unfiltered reflection of the foundation you build during this loading and extraction phase.
Which leaves us with one final thought to chew on as you go work on your own projects. You've seen what it takes to do this the right way. So the real question is your foundation built to last?